So here we've got the lesson on class of elements, lesson 2, and here I've just written a footnote for you. First of all, previous knowledge, all substances are made up of matter, we know that, and matter is made up of atoms and molecules. Atoms are of many kinds, okay, many types. Atoms of metals, you'll have atoms of non-metals and metalloids. And we know that today man has discovered 118 elements, and these elements are classified and placed into a table so that we can study them easily. The next slide will show us the modern periodic table and the way the elements are arranged. So let's look at that. Here we have a table of the modern periodic table as we know it today. And here right in the beginning you see that there's hydrogen here, helium, lithium, beryllium, boron, and so on, right up to 20 calcium. So from 1 to 20 we have taught you all, along with the atomic number, okay, and also electronic configuration, and from that we were able to find out the valency of the element. We have done that in standard 9, right? Now here you can see on the table is hydrogen on the left corner here, and helium is not just next to it, but helium is placed right at the end, right? Likewise, there's lithium, beryllium, and the boron is not next to it here, but it's placed. There's a particular arrangement of the elements on this table that we can see. And the reason for the particular arrangement of elements is, okay, because these elements are placed according to certain characteristics and properties. So in this lesson, we'll be finally understanding how the modern periodic table came to be. Right in the beginning, in the old days, there were not very many elements discovered because we didn't have modern technology, right? So here we see the first scientist many years ago, in the year somewhere around 1800s, okay, there was a scientist called Johann Doberneirs. And Doberneirs, okay, he was a scientist who had few elements that were known and discovered at that time, and he was able to find out among those few elements, okay, groups of 3 elements which had similar chemical properties. So groups of 3 elements he took which had similar properties, and he arranged them according to their atomic masses. Now we must know what is atomic masses first. Atomic masses are the atomic mass of an atom is nothing but the total number of protons and neutrons in that atom. So, okay, so he took those 3 elements, arranged them according to the increasing order of the atomic masses. And what did he discover? He found that the atomic mass of the middle element was approximately equal to the average of the atomic masses of the other 2 elements. Now what do we mean by that? Let's look. Okay, here we have a little table of the few elements that were discovered during his time, and you can see that lithium, sodium, and potassium, these 3 elements according to him had similar characteristics, okay, and he found that if you take lithium and potassium, okay, take the atomic masses, I'm repeating, masses of these atoms, and you find the average worked out to be equal to the atomic mass of sodium. Likewise, for these 3 elements that are highlighted here, calcium, strontium, and barium, they had the similar thing. The atomic mass of calcium and barium, okay, the average of them was equal to the atomic mass of strontium. Likewise, you've got others also: chlorine, bromine, iodine, sulfur, silurium, tellurium, okay, phosphorus, astatine, and okay, all right. So here we have seen this is the same table here. You can see it's worked out for you. Here you got lithium, whose atomic mass number 7, potassium is 39, and if you take 7 and 39 and find the average, that means adding and dividing by 2, it works out to 23, which is actually the atomic mass number of sodium. Likewise, it's worked out here also for calcium, strontium, and barium. Calcium and barium, okay, we found out the average by adding and dividing by 2, and find out that the answer is 88.5, quite close to 87. Likewise, the other triplets as well. And because they were in groups of threes, that is why it was given the name triads. And therefore they were called as Doberneirs triads. So whenever you think of Doberneir, you have to think of Doberneirs triads, which simply says that Doberneier made groups of 3 elements having similar chemical properties, and he arranged them according to the increasing order of their atomic masses, and the average of the first and the last element of the triad is equal to the atomic mass of the middle one. I hope that concept is clear. Right? One more table showing you the elements, calcium, strontium, barium, and the atomic masses, and if you want you can calculate and find the atomic mass to be equal to the middle one. Okay, so I've just put this one more slide for you. You can take a pen and paper and work it out and confirm for yourself. But Dobernier's triads there had some kind of limitations. Okay, so let us look at what were the limitations or drawbacks of his theory. He could identify first of all only some triads from all the elements. Now there was the whole group of table of elements, but from them only few. What about the other elements? The other elements did not